Well, here we are again. I got this little presentation about dash gauges. I'm going to give you a quick run through on this. This is not going to cover every last little problem or every last little system or anything like that. We're going to do a sort of a quick run through and have a little fun here. The Boyce Motometer was basically planted so that it would measure the coolant temperature and you could see it from the windshield. It had a little window in there, you know, where you could, it was like a thermometer basically, and that was something that was patented in 1912, you know, just like you see on the slide. I'm not going to read all the words to you because you can see them as they were written out. There's no water pump on those little Model Ts. Basically they just percolated the coolant up through the radiator and it drained down to the bottom and it went back in, and it was making a cycle like that. So that basically you didn't have a water pump. Some of y'all guys are old car buffs probably knew that already, so I'm just probably preaching to the choir there. The Dodge brothers, though, they came up with some gauges. They got all amps, and that was just pretty cool how they decided to do that. Initially, though, they only had you know, a couple of gauges. They added a speedometer and an ammeter by the end of the decade, and then they put an oil pressure gauge on it. So to start with, they had 2 gauges, then they went with 3 and all that. You know, the speedometers are, I always thought speedometers were really cool, and I enjoyed working on that kind of thing. Beetles didn't have any gas gauge back in until '62. And so the way that they handled that was they had a little reserve tank deal where you would reach down there in the middle of the floor. That's me on my 58 Bug that I used to drive back in the 70s. That thing, Dad cut 125 thousandths off the cylinder heads on that thing and jacked the compression up on it. And that thing was a monster. I put mud grip tires on it. It would go just about anywhere a 4-wheel drive would, because it had all that weight over the back. But the way that worked, you had this that knob down there that you see right here was connected to this, and when you turn that, it would, you know, when the gas got below this pipe, you basically run out of gas. So you turn that and it started drawing from this shorter pipe, and so you had enough gas between here and here. I don't know exactly how much it was. I could have looked that up, but I didn't. Your fuel outlets going out here to the carburetor and all that. So that was something that the Germans came up with on that. It worked pretty good. You know, it had a screen to go over it so it wouldn't get, you know, crud in there and all that. Now ammeters are wired in series. They use a shunt that carries most of the current. The gauge was marked amps, but in the late 70s, voltmeters replaced ammeters on cars. And I remember at the dealership, people that were used to seeing an ammeter would get confused because now they were seeing a voltmeter. And the ammeter usually just sort of stayed close to the middle, but if it needed to charge, you'd see it going. But if it was going the wrong direction, you knew there was something wrong with the charging system and all that. But and it was in the late 70s, I remember, and for, of course, the amp meter stayed on stuff like Ford vans and stuff for a long time after that. And so that was basically something customers really come in complaining because they didn't understand the voltmeter when they'd been used to seeing the amp meter. And I always thought that was kind of funny. You know, now these more ground through the sending unit on these bimetal gauges. This is basically a bimetal strip, and it's got a heater wire wrapped around it. You notice that? And so whenever that, the more ground you got coming through that gauge, there's an instrument voltage regulator that's going to give you a little bit of a flashing current on there. And I used to, basically what I would do when I was checking one of these, I'd disconnect the sending unit, hook my test light between ground and the wire coming from the, you know, that was coming from the gauge going to the sending unit, and I ought to see a pulsing glow there. And if I didn't see a pulsing glow, I either had a bad regulator, and they look like this. I had one out there I could have actually demonstrated for you if I wasn't so lazy. But anyway, if you bench test one of these the wrong way, it'll burn it up. If you actually put power and ground to the back of one of these bimetal gauges, that needle will sweep all the way to the end, and then all this the smoke will go out of this little coil in here. So you need to be really, really careful about testing those things. And if the voltage regulator is that voltage regulation current, you know, it's sort of like a little turn signal flasher, but it's only putting out just a very weak voltage. It's over there. until, here's bimetal gauges again. The instrument voltage regulator, and I mentioned this a minute ago, sends that little flashing voltage pulse to the heater. If it loses its ground, it won't pulse, and it'll just be delivering straight current to the gauges, and every gauge on there will go all the way to the right, and then the smoke will go out, and you'll have to put gauges on it. That can be kind of expensive. It can be difficult if you're working on an old car that you can't get gauges for anymore. So you need to be really careful about that. Grounding the sender would drive the temperature and fuel gauges high, typically on these older ones that have bimetal gauges. And that regulator, flash the light and would respond by sweeping up. Like, in other words, the gauge, when you're watching the gauges on some of them, you'd see them move up. You'd see them move up like, they'd move slowly. Like this right here, and that's because of the flashing of that gauge. Now, you got to be careful on the old ones. I had a Jeep that I was working on, one of these J10, like one of these Grand Wagoneers, and I took the instrument cluster loose from the dash because I was checking for a connection. I didn't realize that the instrument voltage regulator received its ground through the way the dash was mounted to the instrument panel. And when I pulled that thing off the instrument panel and I turned on the key, I watched every single one of these 4 gauges go all the way to the top, and then they went right back to the bottom. And I had destroyed 4 gauges only because I had disconnected the instrument cluster, and that's where it got its ground. Usually the ground's fed through the printed circuit. On that one, that old Jeep, that was a disaster. I had to replace all 4 of those gauges, and it was just, blindsided by that. If you're not, you learn that after one time. Learn, burn, and ruin. Or burn, learn, and ruin. Burn, whatever. My friend Donnie used to say, you burn, learn, and ruin. And that's basically what I did there. Magnetic gauges appeared in the early 70s. A lot of your Chevys, you now notice some of them early 70s Impalas and stuff, when you switched off the key, the fuel gauge would stay right where it was. It wouldn't go down. It just stayed right there. On the Fords, they had an oil pressure back in the. They went with the magnetic gauges in. I'm trying to remember. I'm gonna say it was 1997. No, excuse me. No, that's not right. It was in 1992. They went with those. I don't know why I couldn't remember that off the top of my head. But the oil sending unit transducer didn't work well with the oil gauge, so Ford just put a 22 ohm resistor in line with a contact switch, and it would just read in the middle when you had oil pressure. It wasn't a true oil pressure gauge like you're used to seeing. Now these magnetic gauges, the way they do it, the variable resistor is basically going to increase the ground, and the coils, the way they're laid in there, whenever the magnetism shifts from one coil to the other, it causes a needle to go. Now this is what the gauge will look like if you disconnect one of those magnetic gauges on a Ford or some of these other ones. It'll go all the way up, and then when you ground the wire from the tank sending unit going to the gauge, it'll go all the way back down. And we had a gauge tester with a potentiometer in there that you could set any kind of ohmage you wanted there with 3 different pots, and you could dial the resistance into where it ought to read, with quarter, half, and all that. You could check it all the way through its range. There was also on these gauges a slosh module that they would have. They have to, early in the 70s, whenever the gas would slosh around in the tank, the needle would just waggle all over the place. But they stopped that. Eagle Premiers, which had a very strange thing, they had a dampened sending unit in the tank, so it couldn't move but just so fast. Well, Ford put a little slosh module on the back of their cluster that would filter that signal. And what the problem was with that is, if you're testing the cluster, like for example, let's say you've disconnected the sending unit, you ground the wire going to the fuel gauge, it goes all the way full. When you ground it, you got to switch your key off and back on so that thing will make a quick correction. If you gas the vehicle up with the key on for whatever reason, like somebody listening to the radio and they got it on instead of accessory, or if you do it with the engine running, which you're not supposed to do anyway. That's why the gas cap is on the opposite side from the exhaust pipe, on just about every car. Just look at that. Look at that. See, if you look at the ones that have single exhaust, the gas cap will, if the exhaust coming out the right, the gas cap will be on the left, and vice versa. That's just how that's done. If it's dual exhaust, you know, it's a no-win situation. Anyway, you gas that thing up with the key on or engine running, it's not going to correct as fast as you think. You got to switch it off and turn it back on, then it'll correct real quick. It's just the way that operates. High-end cars went digital with their clusters. Now this is kind of wacky, because these old Lincolns, in spite of the fact they had a digital cluster, it still had a speedometer cable driving it. I always thought that was funny. And then some of your other cars, they'd have this fancy little graph thing, you know, they came up with. You know, I never really liked those things. And I don't really like digital speedometers either, to tell you the truth. I'd really rather have a needle and all that. These liquid crystal diode backlit displays were interesting to me. I got a Thunderbird when these things first came out, and it was a brand new one, and this center was dark. And I really didn't know what pocket to put that in, and after I did my research, there's bulbs behind this that have to be changed, little dash light bulbs, and they come on all the time. On these Eagle Premiers, they got little lights that always come on behind your Prindle indicator down there. And if you jiggle those a little bit when they're on, they'll mess up. You know, basically, if you jiggle it around, what it'll do is it'll blow the bulbs. You know, so anyway, now this right here is the way the speedometer works. This shaft spins, and basically you got a magnet spinning inside a drum. There's no contact here except right there at the tip of that needle. And it's driving it against a spring. And the faster this magnet spins, the more that drum moves against the spring. It's got this eddy currents, so on and so forth, and it pulls that needle on around. Now that's got to be carefully calibrated, you know, whenever they build the doggone thing. But that was interesting to me. The cable connection, this is when I would take them apart and work on them. And so you got a magnet in there, and there's that drum, and the needle shaft, and your cable connection was back here. And I'd put a little drop of oil in there. If the needle started waggling around on some of those Tauruses, I'd take them apart, put just one drop of motor oil in there in this spot right here on that little bushing, and it would make it run just as smooth for the rest of the time they had the car, because that oil would never go away. This is a little centered SINTERED bushing down in there. Now, computer-driven clusters, you know, the 90s brought that around with internal computers driving the gauges. Inputs are either directly fed to the computer or through a network from other computers, and I kind of messed up the wording on that. But if you see all the gauges sweep when you turn on the key, you've got a computer-driven cluster. Now, some of these mid-2000s Chevys have got little stepper motors in there behind the cluster that you can change. You can buy a kit with everything you need for like $35 to change all the stepper motors on your GM Chevrolet pickup instrument cluster, and that is a fun job to do. And we've done some of those over at the school. You got to do some little solder work and all that, but that is an incredibly rewarding and interesting job. First time I ran into one that the gauges on the mid-2000s Chevy was acting crazy, I put a cluster in it because I didn't know any better, and then I found out, well, wait a minute, you can replace these little stepper motors in here. And so we would buy those kits from Amazon, you know. Go on Amazon and get a stepper motor kit for your Chevy pickup. And if you're any kind of a hand with a soldering iron and stuff, they send you a soldering iron, they send you solder, they send a little thing to pop the needles off, and they tell you exactly. You can look, there's YouTube videos all over the place on how to change those stepper motors on them GM speedometers. Now these network-driven clusters, this is a 2007 Cadillac Escalade cluster. The gauges receive input from the network. Every needle is driven by the instrument cluster CPU. I'll tell you what I wrote on the bottom there in just a second. The PCM receives sensor inputs, and it networks it up there to the network-driven cluster. Back as far back as 1999, I ran into a Jeep Grand Cherokee, and the high beam indicator was flashing some kind of a binary code. It looked like it was just flash, 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 flash. I mean, you know, there was some kind of a rhyme and reason to it. But I called the hotline because I had no idea what to do, and there was nothing in the book about it. And they says, oh, you're going to need to put a cluster in that. So I put a very expensive instrument cluster under warranty in that thing, and it turned out that it was the body control module, because what it would do whenever, as I remember, whenever you would pull that thing to change it to high beam, it would send that little voltage deflection in that feed to that body control module would take that command and it would brighten the lights using a relay, and then it would send a request to the instrument cluster to turn on the high beam indicator, and the high beam indicator you know, was flashing because it was getting a screwy signal from the body computer. So we used instead of a $800 instrument cluster, which they first told me to change, it needed a $125 body computer. It was warranty, they were paying for it, and the hotline said to do that, so that's what I did. Module middlemen are annoying on these like these WinStars and stuff. They got front and rear electronic control modules, and the front module handles all the lights and stuff in the front. The rear module handles all the lights and stuff in the rear, and it also handles the fuel gauge input. So the fuel gauge inputs to the module, and the module networks that out to the instrument cluster. And the instrument cluster, if the fuel sending unit fails in a WinStar, the needle will just stay wherever it was when the thing failed, and that'll confuse the daylights out of it if you're not really careful. Watch out for bulletins. Some of these people, I said one student I put over there at a GM dealership, and they kept having inoperative clusters, and these guys popped all these clusters in there and still couldn't fix it, and I don't know what happened after that. But the guy that I sent over there looked up a bulletin, and he basically looked up his bulletin. He didn't replace the cluster. He fixed it according to the technical service bulletin, and he got a feather in his hat from the boss man for that. Instrument illumination is always lots of fun, and you know, there's the need to see the cluster at night. This is the tail lamp fuse early on was basically feed power into the light switch, and the light switch used that same tail light fuse power to feed the fuse panel. If your tail lights fuse blue, your dash lights would go out too, and they had that way, so you'd go, you know, go somewhere to have it checked, and it was basically like an indicator that your tail lights were out if your dash lights went out. Check the tail lights first. That's how that went. That's on the older cars and all that. But that situation there, I mean, there's all kinds of stuff you run into with lights. I'll tell you something else that can happen on these older vehicles. If the how would you put that? If the two filaments in the light in the stop and tail light are shorted together, you'll have a situation where when you mash the brake, the dash lights come on. And that confused the daylights out of some of the mechanics that were working over there, and they'd say, what is going on here? And I'd say, when you see that, take all of the bulbs out of the back and mash the brake and see if that still happens. And if they did that, one of the bulbs would be bad, you know, and it would be, they'd be digging for wiring and all kinds of stuff, and it'd be a bulb back in the back that was causing that. This was a Jeep Wrangler, and it was a crazy thing. It basically, and believe it or not, I created this schematic after having to flip through 7 pages to gather all this information. And some of these Chrysler shop manuals that were drawn in this format are just absolutely insane. And that was back when we were using paper books. But whenever you turn on the ignition switch, it would go through here, and it would go through there. The multi-function switch, you know, would get power from there. When you turn that on, it would go to this module, and that module would feed these dash lights. And so, you know, you could have this dash light issue. If something shorted out, it would destroy the part of it that was operating the dash lights. And the way that I fixed one of these, the instrument cluster was $600 for this, is I just bypassed that dimmer and made it so that those lights were on and bright all the time. $600 to see the cluster at night? I mean, really? I don't think so, you know. But that was on a 93. I'm sorry. What year model was that Jeep Wrangler? I think it was a 93 model. It was a 1993 Jeep Wrangler, if I remember right, a black one. I talked about it on here before, and I went through all kinds of measuring voltages and everything else and tracked this down, and I drew that schematic so that I'd understand it. Sometimes it's a good idea to draw a schematic like this so you'll get a better overview of what the circuit is like. Now on these, some of these Explorers, they have a dimmer. It's got 2 outputs. One output goes to the radio and stuff. The other output goes to the other part of the dash. So if you've got your radio and stuff, it is out on this, but these other lights are working. I found out that it was going to be this unit right here. I found that on several of them. and it would confuse the daylights out of you if you didn't realize that this was feeding off of two different legs in that thing. You had two different sets of dash lights coming off of there. On those Camaros and Firebirds and stuff, they used to have these transistors. These things would fail a lot, and they were kind of annoying and hard to get to. And they were down there, this transistor, it's field effect transistor. You know, the more you fed into the base of the transistor, the more current could go through it, is how that basically worked. And if it had a heat sink, that thing would get really hot, and they would burn out. And we used to have to replace those too. They didn't cost all that much. They had them at the parts house, but they were very annoying. And that looked like a good idea somebody came up with. But you can see how it was wired up here. That little transistor was there, just for your lights and all. Well, the whole thing, don't get in over your head when you're working on an instrument cluster, because a lot of these instrument clusters now are pretty doggone complicated. You can get in a lot of trouble if you're not really careful. And I'm going to end with this. This is my 2025 Ranger that I bought. I just took that video a few minutes ago. And there was a lot of stuff I could have showed you on there, but these new vehicles are ridiculous. I mean, they're almost like playing a video game. You got all kinds of things you can select and move and change your gauges out and all that kind of thing. You know, Ford's been doing that now for about 15 years or more. But one way or another, we're through today. I hope you guys enjoyed this. Hope you got something out of it. We've been here about 21 minutes. And let me know what you think about it. And I'll see you next week.